All right, so PW coming at you, Penner and Wheeler. So this is my turn to shine and take the camera, but John is sitting right here to correct me if I make mistakes, and so we kind of want to just be here to support you guys. And so you guys started today with simplifying radicals, which again, one of the big reasons why people look at radicals is when they're solving something like the Pythagorean theorem. You got a squared plus b squared equals c squared, and you're supposed to maybe work on that. But of course, the other place where in math we frequently see squares is when we're dealing with quadratics. And so that's the unit we're in. We've been studying just graphing quadratics, factoring quadratics, solving quadratics. And so perfect squares and radicals are necessarily just going to be part of that story. So let's go ahead and take a look at how that plays out. Now, what happens when we look at these, this is an extraordinarily simple problem. And what many students will do is they will immediately see, oh, hey, what number being squared is 36? They're going to jump in there and see the number 6 and be like super happy. They've got it. That was the easiest question in the world. In fact, I saw a couple of my own students just this last Friday do a problem like this and have that happen. But I want to remind you that when we graph parabolas, so you keep in mind, this would just be the graph of the parabola x squared, which actually is the easiest parabola that we have. It just looks like this nice, simple little guy. The number 36 is a horizontal line. Well, what you notice right away is you don't have one solution. It's true that it hit over here at the number 6 comma 36, right? So that value is a good value. It's not like this is a bad solution. It's just not a complete solution, because if you also square -6, you would also get 36. So we don't get one answer. We actually have two answers. And so most math people like to write that with a plus or minus sitting right here, indicating not that there's one answer, but there's two. So if you ever see this and you take the square root of both sides, that's where that plus or minus is going to start showing up. Now, this problem right here is actually almost the same problem, but written in disguise. Notice here, I directly put x squared equal to 36, but right here it was x squared minus 25 equal to 0. Well, okay, so in the previous unit, what we've been talking to you about is to go ahead and look at this and think about what numbers would factor. And in this case, I would want two numbers whose product is -25, but whose sum is 0, because remember that b term that we talk about is missing. So a +5 and a -5, if you were to distribute it, would be x squared. The +5x and the -5x would cancel. That's why there's no b term. -25 is 0, which leads us to the solutions like we did literally last week, that x equals 5 would make the zero product property work here, and -5 would work here. In other words, plus or minus 5. But the nice thing is in dealing with this idea of radicals, instead, we could have looked at the problem this way. So if you don't have a b term, that's really important. This is just what you do if you don't have a b term. Simply move the c value across. And now we're back to this thing right here, where when we take the square root of both sides, as Wheeler said, those are inverses, the square and the square root cancel. We're going to be looking at plus or minus √5. And it just makes a very quick solution, but it's not different. It's just a different approach. So, of course, we're not going to stick with that, because I think that would be kind of boring if we were doing only problems that are quite that easy. So sometimes someone's going to come at you and go like this. And boy, I know so many people are going to get hooked like a fish on this one, because that's what we're trying to do. It's like, hey, what number when I square it gives me -4? And so people come in and they take the square root of both sides and they're like, hey, plus or minus 2, I got it. I got that. But wait a minute. Aren't we always supposed to check our answers? And if I were to plug in 2 squared, I don't get -4, I get +4. And if I get -2 and I square it, that is also +4. It seems like there's something missing here. And that should actually kind of line up, because in the original problem, we said, hey, where is x squared? Remember, I just mentioned this is what x squared looks like. -4 would be a line down here. And well, where do these two lines cross? They don't cross like at two places like this one did. They just don't cross at all. So what we're going to say, this is awesome. Now, a lot of people will do this wrong. A lot of people will say no solution, but that's wrong. I don't like to lie to you guys. I really don't. I like to treat you like adults. That is not the right answer. The answer is no real solution. That's a little bit of a hint that there is a solution. It just doesn't have to be what we call real, because this guy named Bombelli came in and he did something kind of cool. You'll like it because otherwise, without Bombelli, you don't have cell phones, you know, lights, any electricity. It's just kind of significant. So anyway, not that anybody ever uses math, right? But anyway, so Bombelli did some cool stuff. And so that's going to be a little bit of a hint that there's going to be something new. So just watch for it that you don't get hooked on these silly guys. Okay, so let's go a little bit harder. X minus 1 quantity squared is 49. Now, this time it wasn't just an x squared, it's an x minus 1 squared. But no big deal, it's still this nice, easy, perfect square. And if I took the square root of x minus 1 squared, no big deal. And we saw up here, when we take the square root, we get that plus or minus. So again, I want x by itself, so let's add that 1, and here we go. So we've got two solutions. When it was positive 7 and we added 1, we got 8. But if it was negative 7 and we added 1, we got negative 1, negative 6, right? Now, it's always important to go back and make sure our answers work, because we don't want to make the silly mistake like what we made up here. So let's see, what is 8 take away 1? You can see that that would be 7, and that square would be 49. Negative 6 take away 1. Square that, we would also get 49. So that again does make perfect sense. So let's keep it going a little bit tougher. How just like that previous set, we sometimes don't set it directly equal to the value. Sometimes we go over here. And so this again is one of those cases where the smart play is to isolate this perfect square that's sitting here by bringing that to the other side. Now it turns into this problem where we take x plus 5 equals plus or minus 4, because we took the square root of both sides, move that 5 across, and we're looking at positive 4. Take away 5 would be negative 1, and negative 4 take away 5, which is negative 9. Now, for me, when I do math, I always like to make sure that I'm doing good quality work. And sometimes we make careless mistakes. So I actually really, really like being able to grab Desmos, which you've seen me do quite a lot, in that you can take something like x plus 5 quantity squared, and you got this nice simple parabola going on right here. And I wanted to know, where was that thing equal to 16, right? Now, that's not on my screen, but no big deal. I should have said y equals 16. And what do you know? There's my two answers. Y equals 16 is here and right here. And notice the answers that I got a moment ago on my page were -1 and -9. And you can see quite clearly on the graph that that's where they hit. And keep in mind, each of these would be represented as a y equal. So that's really nice that you can check your answers, and you could also do that on a graphing calculator just as well. So, well, you know, as Wheeler did just a minute ago, not everything is going to have these perfect solutions. Sometimes we have these things that are a little less pleasant, that are irrational. So let's check out a couple of irrational problems. So this time we're going to just go simple. X plus 5 quantity squared is 18. Now, again, same as before, we had it all by itself, so x plus 5. But hey, Wheeler was telling us how to play Go Fish. So when I look at the number 18, I see 18 would be 2 times 9, but 9 is 3 times 3. So if we're going to play Go Fish, you're going to notice that we have our little pair of 3s right here. So we had 3, we had our pair of 3s, and we had the 2 left in our hands with that plus or minus. So that's okay, but we have one more step to go, and that means we found that x is -5 plus or minus 3 roots of 2. Now, that's a little harder to look at in its representation. So like I said, let's go ahead and take a look at Desmos and see what that actually looks like. So I already set this up before. We had x plus 5 squared, but this time we're going to be looking for where that hits the number 18. Now that's kind of weird, but it's right here and right here. So notice the 18, but what I'm going to do is I'm going to try something. And instead of what's there, I'm going to try negative 5 minus 3 square root of 2, comma, 18, because that should have been the place where they hit. And what do you notice? That did actually do that. And I'm going to grab this same thing because remember it was just plus or minus. And if I change this one to a plus, you'll notice again, the place the x value, because keep in mind, that's we said x was that, and that generated the answer 18. So I think that should be fairly clear. So sorry to kind of keep going on this, but Mr. Wheeler and I discussed what we thought was really significant, and we wanted to make sure you guys just didn't get part of the lesson. We wanted to make sure that even in distance learning, we made sure we got it all. So we wanted to do a little bit more advanced problems. Up here, this was super easy. Down here, you know what? The perfect square is not isolated. There's all this extra stuff going on. So remember when we do PEMDAS, which is kind of our rule about how you evaluate expressions, but when you solve, you kind of have to go backwards. So usually what we tell students to do is get rid of the adds and subtracts first. So let's do that. That's going to be 144. And we did this on purpose to trick you because almost all of you right now are seeing, oh, sweet, plus or minus 12, right? You've got that number. But wait a minute, I'm still not there because now I need to get rid of this multiply and divide. So let's divide both sides by 2. And boy, I just screwed it up, didn't I? It's not a perfect square anymore. Shoot. Actually, for me, I'm kind of happy because that would have been boring. So let's take the square root of both sides. And we've got x minus 7 equals plus or minus the square root of 72. Now, you could hit pause for a second and see if you could simplify that root for me if you want to. I'll give you a second to do that right now. Okay, so let's figure it out. What was 72? Well, again, noticing that perfect number 2 going in is okay. And some people are going to keep going, but I hope most of you can see right now you got a pair of 6s, don't we? So we've got x minus 7 is plus or minus 6 roots of 2. And then the only thing left to do is to move that 7. So if we added 7 to both sides, we've got our nice little solution. And okay, sorry to make this a little bit lengthy, but again, we just want to make sure that we're good to go, and we have not. Hey, what do you know? The bells even go off on our days off. Okay, so just like the previous problem, what should we do first? Yeah, of course, we're going to move the 5. So, and I don't care if you write the plus 5s. I really don't. If you just do that in your head, I'm good with that. Then, of course, we need to get rid of a 1/3, but that's kind of weird. And a lot of people will say divide both sides by 1/3. That's true, but dang, it's so much easier just to say multiply both sides by 3. So if we multiply by 3, this is gone, and this is 15. And I don't know, I'm a little lazy sometimes myself. I actually love it when I get numbers like 15, because when I go to take the square root of 15, remember when we take the square root, we get that plus or minus. 15 is 3 times 5. And this is that time when Go Fish are like, well, darn, I don't have any pairs. I'm just kind of stuck. I just have to wait until my turn. And that's what we got. So we are off to the races. And there's my answers. -2 plus root 15, -2 minus root 15. And the last problem in our story is right here. It is the hardest one. It's when someone is a little bit extra aggressive, and occasionally you'll have a problem where you don't just have an X inside. Oh, shoot. Well, I guess we better take the square root of both sides. That's plus or minus root 20. Of course, 20, that's a 5 times 4, but 4 is a couple of 2's, isn't it? So it looks to me like we're here. Now, again, as I mentioned before, when we do solving, we always do PEMDAS in reverse. So some people are going to say get rid of the 2 first, but that actually kind of violates what we're supposed to do. I'm going to take 3 away from both sides. And then the only thing left to do would be to get rid of this 2 right here. So I'm going to divide both sides by the number 2. And so I have this answer right here, which some people like to write it this way. Some people will write it over here as -3/2 plus, notice 2 roots of 5 divided by 2. Notice this 2 divides into both of them, plus or minus the square root of 5. I actually personally really like this version right here because coming up very soon, Mr. Wheeler and I are going to teach you guys this special thing called the quadratic formula. And there's a reason that a solution that looks like this is going to pop out of there. But this is actually the kind of answer that you'll see in the book. In fact, in your textbook, if you looked at the answer key, they will say this, or they will say this, and they will completely separate them. But Mr. Wheeler and I kind of like the plus or minus notation because it's efficient and it just is what naturally pops out of the math. So hopefully that's going to work okay for you guys. You're going to be working through a few problems on your own, and we will see you back in class soon. Hopefully that was helpful. See ya. Bye.